Okay, well, um, I'm gonna go ahead and just record this. I'll play it probably tomorrow. And yeah, hope you guys enjoy this. I'm going to be working on the Game of Game of Life by John Conway. So it's a programming project that I find very interesting. Um, so what we've done so far, just so you all know, um, we oops, do this. Um, so what we have so far is I used someone's Qt project, basically. And it has a very nice UI already that I'm going to make use of. It's pretty nice. It does exactly what I want it to. It simulates the game of life. It also lets you do fun things like click on spaces on the board and make things happen. So you can add cells to it. I think it probably toggles. I haven't really looked at it. So you can see we're getting a lot of fun stuff going on here. The aim of this project, as I said in the previous video, is we want to make the cells a little bit more interesting. So they'll have certain qualities built into a DNA of sorts that allow them to do fun things. So if I go into support.h, I'll show you what some of those things are. And actually, this is not what I was expecting to be in here. Let me see where I am. So that should have something different in there. Hold on, let me go up. .h. So that's weird. You can see that's not what is over here. Maybe I didn't open the right project. We'll close those tabs. Do not save. So we'll go to here again and open a project. Hopefully this one will probably come up and say there's problems. I completely anticipate. Let's make sure that this has the right. Yeah, that has what I was expecting it to be. I expect this to blow up, I think. I don't think this will work. Maybe I'm wrong. Okay, good. So yeah, there were some issues that I needed to work out. What I do like though is I found out about bit fields. I know that many people probably already know about this, but it's something that I had forgotten about or didn't know about in the first place. So you can see what we did is I created some other structs that allow us to kind of compress the data structures a little bit. So what we can do is now we can reference the direction struct inside of behavior T. And that's useful. That way we don't have to guess around or do bit masking or other things. Lets us be very specific about where we find stuff. I was also able to make all of my structs a size of integer large. So what that should allow us to do is make random integers of a certain size and then cast them to this behavior type. So, and that was the aim from the beginning, to have that kind of ability. Kind of get some stuff set up over here. I'm still kind of learning the whole the streaming thing, so be patient with that, I guess. I try to figure this stuff out. Okay, so let's get going. Let's try and the first thing we want to do is get rid of these errors that we're seeing down here. So what's going wrong here? Oh, yeah, that would be the problem. So in C++, you have to have some sort of type. In this case, I believe this was void. Void. I should build now, I think. Okay, so now we need to make this match our new implementation. So let's see, can I open this up? Split window. Split side by side. That's what I want. We'll open up support over here. So let's do int temp DNA. We want to be a little bit more specific here. We'll do uint 64 underscore t. So that'll give us a 64-bit unsigned integer. And we'll do look up. Oh. Good. Uint 64. X. I think we want max plus 1 there. It doesn't really matter. It is a random number. So then what we want to try and do is set DNA equals, this is an interesting trick that I learned, to do a cast like what we're trying to do here. We actually want DNA. I believe it's like this. And then we want so what this does is it takes this temp DNA and it makes it, well, it makes a random temp DNA, which is just an integer. And then what we do is we tell the compiler, hey, just pretend this is DNA. So we pass it a reference to this int, and we say, I promise that this is a DNA type. And then we dereference that because we want the copy. So if you think about it, temp DNA ends up in memory. So what we do is we check what the address of that memory is. And when we find out what the address of that memory is, we look at that, we say that, okay, that pointer right there, that is a DNA type. And then we dereference it, so that comes out as an object, or in this case a struct, that we can then copy into the DNA type that we have here. So that took me a while to understand, and I'm probably not giving it justice as far as what we are doing here, but that's the best I understand it. So we'll do the same thing down here. Max plus 1. And the reason, I didn't explain this earlier, the reason that we want this to be plus 1, and actually I'm going to put this in parentheses, is because when you do a modulus operator, so if you're modding by 255, then the highest number that you can get is 254. So you need to add 1 in order to get the correct maximum number, is basically what we're doing here. So we'll say behavior equals behavior actually, I did this wrong too. No, I did that right. That is correct. Okay. Behavior. Okay, so let's see how badly we've screwed this up now. Division by 0. When in doubt, add more parentheses. Let's try that again and just see if we do the same issue. Not convert DNA star in assignment. So, because I don't know what I'm doing wrong, I'm going to look this up. C++. I saw the way to do this with a union. I like the other way better though. It's more what I'm looking to do. Not to say that it's the more correct way. Yeah, so this pointer casting is what I really want to do. Because that's not working, let's go ahead and take out some of these parentheses here. Maybe that's screwing us up, actually. Let's see if we get rid of that warning, or error, rather. Let's look back over at solutions I have so far. Pointer casting. Okay, so the correct way to do this is probably memcopy. I don't want to do that. Oh, for sure I had this before. Choose the wrong type. Oh, that's why. You need to dereference this. So, here's the thing that I forgot. I forgot that, I'm gonna comment this. Pointer cast to DNA from UN before T. I forgot that DNA and behavior are both pointers. If I would have gone back to my cell.h file, I would have known that. This is 32. Let's make that more explicit. Okay, let's build that. That should solve our problems. Okay, now we're dividing by 0. Where? Okay, we could potentially get 0 there. That's fair. Actually, yeah, that would be 0. So we might not be able to get all the way to the max. I don't really care. It's going to be random anyway, so the likeliness of getting that is pretty small. Okay, so we have so just because, let's do a clean all. Okay. Clean all. Okay, now that we've cleaned everything, let's do another build. So because we're using Qt, sometimes there's weird things that happen with mock. You can get bad mock files that depend on earlier things and doesn't, yeah, anyway. It's the same as any build process. If you have something weird that you don't understand, go ahead and do a clean and then see if it happens again. Likely what's happening here is I have mutate as a plot, but then I never define it. Yeah, I never define it anywhere. That's what's happening there. Good thing is, seems like our random generate functions are good. So next thing, just as a quick test, gonna main and up above. Well, after application, let's do now. Just comment these out. We don't have them yet. And go again. Okay, so let's go back to main and just make sure that we can access everything. What I'll do is cell.h. We'll say cell test. So this should create a random cell. So we can do test dot. Let's, for testing's sake, let's make these public for now. These will move back down to private or protected. Make these protected. That should allow us to go back over to main and say test dot underscore DNA dot let's do this. Qdebug I'll say age of reproduction. And what? D. Leave. We'll just do a quick QA of these things. The thing I'm most interested in is in the behavior portion. Gonna suck for this dude if lifespan's shorter than the age of reproduction, I guess. Considering that's its purpose at this point. Actually, you know what? Let's just go down this list. I want to see what this looks like. We'll do X here. X. I think I want third pound X. We'll see. Thank goodness for Smart Complete. Sorry this is taking a while. It's just want to make sure that I look at all these things, and I'll keep it up here so that I don't have to type it again. This should be a one and done thing. Movement. Theoretically, this should be one, but it is now. Okay, DNA is done. Now let's do behavior. So first I'm going to do the debug up here and say DNA settings. Tab. Still never figured out if there was a lock. A way to rectangular select. I'm not happy about something here. Oh, so. Okay, so then we can do this. Your settings. And do test. Underscore behavior. Dot. Okay, now here comes the moment of truth. Learned bacteria. I hope this works, because if it does, that makes my life so much easier. I don't have to think about it again. So we'll do another one of these. qdebug \t learned. And then this will be 2 tabs. Bacteria. These are, of course, are in alphabetical order. I don't know where they are, actually, in the truck, and for the most part, I don't really care. And of course, we're doing that again. These should all equal either a 1 or a 0, theoretically. Hopefully they do. Oops, that's not food. Okay, maybe the audio is a little bit better here. Oh, sorry about that. Poison, predator. Tainted. Maybe I said this in the last video, but tainted means it's going to be tainted food. I don't figure we have to worry about tainted predators. Although maybe we would have to worry about tainted cells. They're going to reproduce. Maybe they won't reproduce with something that's tainted. Not a bad idea. Oops. Dot. So be able to tell if another cell is infected with either virus or bacteria, because some of those will probably have some sort of gestation period or something like that. I don't really know at this point. Virus. Then take this. Opinion. Opinion. That was much faster. So let's now we'll do. Oops. This will be a different heading. Not really sure what it is though. Possible direction. I know what's going on. Possible directions. North. South. Yes, I am not doing good with semicolons tonight. Go. And the next one is preferred directions, I believe. Preferred direction. Preferred directions. Okay, so let's give that a build. Hopefully it works. Uh-oh. Why? Where is it? Where else it is? Include it here. No. Yes. Pardon me 1 second. Go with it. Oh, yeah. What did I forget? I mean, I can do that, but you have to be this. Use of deleted function. I am so confused right now. I thought I knew how to do constructors in C++. But look. So does it? Apparently that worked. But I didn't get any output. Okay, well, let's take a look at QTQ debug. I'm not really sure what I'm doing wrong here. Debug not working. From a few years ago. just after the exec. I'm hoping that does the trick. Sorry if you guys aren't getting any of this this music in the background. It's supposed to be playing, but I honestly don't know if it is. It is there. It's quiet. Okay. Not getting any QDebug output. Annoying. Okay, well, to make this easier, I'm just gonna do include the standard IO. That goes in this. And we'll just change all these to def. Okay, maybe the audio is a little bit better here. I hope. Sorry about that. Try again. Replace. Find QD debug. Place with def. Okay. It builds. Good, it builds. Probably in the debugger console. That's probably why I'm not seeing. Oh, there we go. Okay. Oops, I don't want \n. Okay. This one didn't learn much. Let's just not at all what I want to do. Okay. So let's just go ahead and run this a couple times. So we get different results. It worries me that size, tolerance, appearance, all these here are always... Oh, no. We got a 1 there. Okay. It does worry me that these aren't getting anything. If we... Why do I see nothing in appearance, size, tolerance? I never see anything in learned or opinion. No matter how many times I run it. Just so you guys know, this is up on GitHub. I'm going to need to stop here pretty soon with my stream, but this is up on GitHub, and I encourage you to go check it out. If you see any issues, please let me know. Feel free to add them to this issues tab here. And I'll be sure to put a link to this in the notes for this. So yeah, it'll be up there. In fact, since we are building properly, I'll go ahead and put that up there now. Oh, and by all means, if you happen to oops. Feel free to also submit feature requests or other ideas that you might have, because I'm super interested in making this as well interesting as I possibly can. There's a lot of cool things that we could do with this, or I could do with this, or we all could do with this. So yeah, feel free to fork this anytime you want, and hopefully it provides some interesting exploration into this specific, very small window of artificial intelligence. So yeah, enjoy. Thanks for watching.